Greetings, my fellow software test engineers, and welcome to the Software Test Automation Revealed YouTube channel, STAR for short, hosted by me, Cody Gibson. This is episode 2, where we're going to do a deep dive into the global data cache, what this is, and how this is advantageous to our tests. But first, would you please click that like and subscribe button along with the notification bell so you can be notified as I upload new videos to YouTube for you. Thanks. Now let's look at an example of a common test problem for us. We can see here that, let's say for example, we're on page number 1, in this case a product page, and we can see we have a price here. We can also see we've got a coupon indicator, and we can also see we've got the price duplicated up here. So what we want to do is we want to verify that this price, and this coupon are correctly displayed as we move forward into the next page, page number 2. In this case, it's going to be the shopping cart page. So we want to verify that the price displayed here, the price displayed here, along with this coupon information is correctly displayed in page number 2. Using the global data cache, we can literally scrape the screen. We can capture this price information, along with this coupon information, save that in our global data cache. Then when we move forward into page number 2, our shopping cart page, we can recall that information and we can verify this price matches what was captured, this price matches what was captured, and this coupon information matches what was captured. All right, how this is going to work, what we'll do in our test code is we actually have a static global data dictionary. We have one data dictionary which will have a host of other data dictionaries. Each data dictionary provides the data for one test. So every single test has its own unique data dictionary cache. Test A and B and C. Inside each data dictionary, we will have a whole bunch of POCOs, meaning plain old C objects. We can store a large set of them. We can have version A and version B and version C and so on. Each one of these would be basically representing a class type. We can actually use the same class in each of these data dictionaries. Because there is no overlap from one dictionary to another, it is perfectly thread safe to use the same C object from one data dictionary and another, because this is test number A and this is test letter B. Because this is test letter A and this is test letter B. There's no overlap, perfectly safe. And then we have one global data dictionary. As the tests are executing, the test can literally look up its data dictionary from this static global data dictionary, pull it out, and then get the C object it needs for test letter A. Or if test letter B is running, it can pull out its data dictionary and get the C object A that it needs. All right, now let's go ahead and have a look at some code. All right. Wait a minute. Excuse me a moment. Let me get rid of these aliens that are trying to invade us, all right? All right, I think that's better. So let's have a deep dive into the code. We can see this is that outer dictionary right here. We've put it into the base web test. This is going to hold all of the data cache dictionaries for every single test that is executed. This then is used further down here. We have this data cache method. What it's going to do is when a test calls it, it's first going to say, try to get the data dictionary for the currently running tests. Now it knows which is running because NUnit has this static property and it's got a unique test ID. So every test that it's executing actually has a unique ID That ID is a string, so that string is used as a lookup key into our data dictionary. Once that lookup succeeds, then we have our data dictionary for the specific test executing, and we're going to try to get the C object. We're going to use the type of object that the test is looking for as its lookup key. Once that succeeds, then we can return it. And because this is generic, we can typecast it into the C object type that the test is looking for, and we can return that directly. So we've got ourselves a strongly typecast C object that the test can use. Now let's suppose that the lookup for the data dictionary for the currently running test fails. So what we're going to do is we're going to create a new dictionary for that test to use, and we're going to add it to our global static data dictionary so it becomes permanently available. That allows the data dictionary, the global static data dictionary, to grow on demand. Once that's finished, then no matter what, let's say we do find it, but we don't find the object, or we do have to create a new data dictionary. Either way, we know we have to create a new C object. So we create one, we add it to that test's data dictionary, and we also return it to the test that is executing. That's how this works. Pretty relatively simple, sort of like a little bit of black magic now. So how does this work? Well, let's look at a specific example. I've modified our dinner page. I've adding data into the data cache. So right here, I am storing into what's called an announcement. And this is a type, call it simple POCO, which is from here. This is our simple POCO. It's nothing more than an announcement field being stored as a string, and that's being used on our dinner page. So we can literally say test data cache, and this is a method, so that is going to fetch the data dictionary, and it's going to fetch that specific C object for us, and then we can reference the .announcement field within it, and we can set its value. Then later on, in another follow-up method, we can do an assert. We can say verify that the dinner message, which is being passed in as a parameter here, matches what was previously stored in our global data dictionary. Looking at the test itself, this is how that test is using it. So we have our dinner. We take a dinner message. In NUnit, I'm passing dinner message as a parameter, so that becomes a parameter into our test. I can then feed it. So this first step will set the message in our global data dictionary, and then in action 2, that does the assert. I'm doing the same thing for every other page on I'm doing the same thing for everybody. I'm doing the same thing for every other page object in this test. So home page, I've done the same thing, although it uses home message instead of dinner message. Did the same thing for country, as well as we already covered dinner and the feedback. So all of these are doing the same thing. It's following the same approach. Now let's see this execute. All right. And we can go to our Test Explorer now. And we'll expand this to see all of the results. I previously ran this and see that it passes. And let's go ahead and run this. Now it's going to be a little hard for you to see, but it's launching 4 separate browsers, and it's running those browsers simultaneously. So in a moment, it's going to size them there, okay? Browser 1, browser 2, browser 3, browser 4. I'm switching between them fairly quickly, and it passed on all of these, which also proves that things are thread safe. The other change I made was I added this parallelizable scope. I'm telling NUnit it is safe to run all of the test cases in parallel. Because of the way these parameters are written, NUnit combines all of these in every possible combination, which comes out to 4 different combinations, 4 different types of parameters that can be put together to create the test. All right, so now, appreciate that. Thanks for tuning in. And that's the end of this episode. And I look forward to seeing you in the next episode, episode 3, where I will be introducing you to what I call fluent style assertions. Thank you very much and have a good day. And also, please remember, click that like and subscribe button along with the notification bell so you will be notified when I get episode 3 uploaded for you.